Okay, I think you're going to like this, and I think it's going to make sense. I really, 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 really hope so. The first thing I need you to do is take out the worksheet on, oh, it doesn't have a name, but it says it's easy to calculate the average value because I gave you that worksheet and I want you to follow along. I want you to do what this paper says. So let's read it together. It's easy to calculate the average value of finitely many numbers. So what does it mean to calculate the average value of a function that takes on infinitely many values over an interval? So here's a graph of temperature over a day, 24 hours. And we want to find the average temperature over the course of the day. But it depends on how many readings you take. So if you do number 1 and you take the temperature at 0 and you take the temperature at 24 and you average them together, you're going to get 64.208. I'll tell you that one right now. But watch what happens when you take more readings when you do number 2. And I actually want you to stop the video and do this and see what you come up with. And hopefully, I want to show you a really easy way to do it on the calculator because I'm not sure you'll think of it, and it's really important that you start learning some shortcuts on the calculator. So let me show you quickly how to do this. As usual, we're going to put the function in y1 because that makes our life really easy. So we have 70 plus 2 sine x over 2 minus x over 2. Make sure you're in degrees because it says that the temperatures are in degrees. And now I'm good. My function's in y1. It says, what's the average temperature over the first 3 hours if you look from each half hour where t is 0.51? So on my main screen, I'm going to go, I already know what it is at 0. It's 70. I'm going to do 0.5 stow x, and then I'm going to do alpha trace to evaluate it in my y1. And then I'm going to go 1 stow x, enter, alpha trace to get y1, enter. Then it gives you all the values. So I need you to do that for all the values up to 3 hours. You should end up with, I believe, 7 readings. 1, 2, 3, 4, 5, 6, 7 readings. And then you're going to divide your answer by 7. What's going to happen is you're going to get 69.276. Then I want you to do it for every 20 minutes. Yes, I know it's going to be annoying, but you will see the fruits of your labor, and this will make so much more sense to you if you actually do these 3 things. And then once you're done, I'm going to explain to you why this works. We know that an integral adds up a whole infinitely many rectangles under a curve, right? That's what it does. Well, if we want to find the average value of a function, then we want to average all those rectangles together. And in order to do that, we need to use the following formula. So this is average value of a function, not to be confused with average rate of change, and not to be confused with the mean value theorem. This is average value of a function. The formula for average value of a function, given a function that is integrable on the closed interval a to b, then you can find the average value to be 1 over b minus a, the integral from a to b of f of x dx. So let's go back to the temperature question again. We know the function, is 70 plus 2 sine x over 2 minus x over 2. Now, I'm going to integrate that from 0 to 20. Oh, sorry, it was for the first 3 hours, wasn't it? So we're going to go from 0 to 3. So the average value of the function is 1 over 3 minus 0 is 3 times the integral from 0 to 3 of this function right here times dx. Now again, we're going to use the calculator because it's awesome. Here's what it looks like. I still have that function in y1. So all I have to do is alpha y equals 1 over 3 times the integral, math 9, from 0 to 3 of y1, alpha trace y1 dx. And what you found after finding all of those averages is that this is exactly the same as what you got by taking the averages. So don't confuse mean value theorem with average value theorem. Average value has to do with integrals and the average value of a function. Mean value theorem for differentials means there's a point on the curve where the derivative is equal to the slope of the secant. There's also the mean value theorem for definite integrals. That at some point C in A to B, that the f of C is going to equal that average value. Meaning, over the course of those 3 hours, if the average value is 69.276 degrees, then there's got to be some time where the temperature actually equaled 69.27 degrees. Okay? So, average, I want to show you this too. I really want to make sure you understand these. These are very confusing. Average rate of change is the slope of the secant of the function. Instantaneous rate of change is the derivative of the function. Mean value theorem for derivatives means there's a point in the interior where the derivative equals the slope of the secant, and the C is the actual point where that happens. Average value theorem for integrals, average value, is 1 over b minus a times the integral from a to b of f of x dx. And then the mean value theorem for integrals says that there's a point C somewhere in that interval that equals the average value of the function. So listen to that a few times, make sure it makes sense, and you're going to try some problems.